put on the, it is what, just a second, where I have used where it is recorded, just a second. One second. Yes. So let's take few example based on this inverse transformation, and then we have one example based on convolution method, and then more example based on acceptance rejection method. So examples we are going to take very quickly because these are very simple examples. So first example you can consider for uniform. So let me say uniform with a comma b. I know you can obtain the CDF for this, so I'm just leaving on you. You can just obtain the CDF x minus a upon b minus a. Okay, so using inverse transformation method, what is the steps? You can select the random number u from uniform 0, 1, and then using transformation method, using inverse transformation technique, one can say that f of x is equal to x minus a upon b minus a, which is same as we have considered it is u. So this is become x become a plus b minus a into u. Okay, so this is your required observations from uniform a comma b. Okay, this is very simple. I have just used, you can just obtain the CDF for this and follow this step, generate u from uniform, then f of x become u, so you can get the inverse of this, it will give the required observation. The same step you can follow. This is we have already done in our individual classes, so I'm just going very quickly to finish this part. Similarly, you can do for exponential. Let me know if you have any query in between also. You can interrupt me and you can ask the query. Exponential. So you can just consider PDF, which is 1 upon lambda e raised to minus x upon lambda. Lambda will be positive, x become positive, right? One can get very easy to CDF also for this. So 1 minus e raised to minus x upon lambda. Okay. So again, the steps is common. You can compare, select the random number from the u, uniform 0, use inverse transformation method. F of x is equal to this quantity. So f of x become u. So this become 1 minus e raised to minus x upon lambda, which is u. So you can just taking log, simplifying everything, you can get the value of x become minus lambda time log of u, because u and 1 minus u both are either this you can write, or you can write it is minus lambda time log of 1 minus u. Both will be the same result, because u and 1 minus u both are the random observations. Random numbers. Okay. Then we'll have some problem based on this, how it works in now. And third one can let us consider for the gamma, because for gamma, you know, it is not possible to find out the CDF for this distribution, right? So one may not use this, you can say, inverse transformation method, but you know, we can use the concept of convolution. So first you have to generate from the your exponential distribution. So you have written already steps for all exponential distribution here. You can just copy this entire thing and you can write the result for that. Since this result is true for maybe you can say for suppose xi will be generated. Okay, so write derivation 2 first, derivation 2 entirely first. Okay, and then you may say that result. What is the result? So let's say xi.
Convolution.
Lambda time ln of ui, I is running from 1 to n. Okay, so y become summation of your xi, I is running from 1 to n, which is same as minus lambda time ln of its product of 1 to n ui is the required observations. Okay, but here we are supposed to write the result. What is the result? Gamma with parameter n comma lambda is the sum of n independent exponential variable with parameter lambda. Okay, so first we need to generate the observation from the exponential, okay, which is the derivation number 2, and then you can consider y is a sum of your all generated random variable from the exponential. Okay, so this y will be your required observation from gamma distribution. Just a second. Just go through student. There's some background noise, so just keep it mute. Just go through and let me know if you have any query. Then students, any query here? The third derivation. Yes, anyone? No query. Go to chat box, write down why if you have any query, or just write n if you don't have any, no query. Just write n in the chat box if you don't have any query. Fast, quick, quick. 25 students have attended, so I just want response at least 50%. Just write small and if you do not have any query, so that we can go ahead. Quick, quick, quick. I'm waiting for response, students. Ashwarya, Devang, Karthik, Rav, Shman, Shweta, fast. Acha, by the way, tomorrow you don't have any lectures? Devang,
Yes, sir.
what happened tomorrow? Some classes there? Like,
Sir, actually, one company's placement is there, so
okay.
that's why.
So what time you have the placement? Like entire day?
Sir, it will be from 1 to, it will start from 1. So in so before 12 it can be managed. Lecture.
So before 12, like, so okay. So it is online only, na?
No, sir, it is office.
It
We have to
isn't.
go to the office.
Okay, okay, okay. Then it is not feasible. Okay, fine. Then I'll keep extra class on Sunday. It's a fine then. So Sunday you don't have any placements. Can we keep it on Sunday? Sunday then, because you want to finish your portion or not?
Yes, sir, that will be fine.
That would be fine, na? Because see, anyways you have to finish it within these 20 days, and then your then regular placement will come. Then regular some exam will come. Then some holidays will come. Then how would be we will complete our portion? Because I have to mind of everything by the 31st March. It's like a financial academy. So I will keep on this Sunday. Okay. So I will inform you the time. Hopefully it is in morning only around 10 to 12 and like that. Okay. Is that okay to all students if it is in morning? How many says we'll go with morning? Just write why 10 to 12 around. Sunday morning 10 to 12. Just say why. How many are agree with this, so we can go ahead with it. Because we want to finish our portion. Otherwise, I will just go very quickly and you will not understand anything. Then that should not be happen, na? So जो पढ़ो अच्छे से पढ़ो, थोड़ा ही पढ़ो चलेगा. But that is the main thing we require. Okay, so majority says we'll go with this 10 to 12 on Sunday, so we can try to finish it maybe this method. This means at least we can do with the R part here. And for at least inverse, then acceptance decision method will continue with the next class. No problem. Okay. So let's take for a few problem how it runs, how it works in R, or at least for 1 2 example like this. So I'm just sharing the screen for look at this. Before I'll take this, I just wanted to say if you can use this book. I'll share this both the book. Both books will be getting the hard copy of this, even soft copy also. Just try to see whether if it is possible for you to go through at least a part of some pages from that book, it would be better, because there are so many examples which we are not going to cover the more examples. Few examples which are the little not very easy, not very difficult. It is just moderate type. You can take those examples. Okay. So this I have used the book name is Introducing the Monte Carlo Using R by I think it is Calesa, if I don't remember. It's a Calesa, I think, author. I'll share that book today. And another book is Rose. Maybe a second, whether I have that book with me or not. Just yeah, statistical modeling and decision. It is simulation. Book name is Simulation by Seldom Ambrose. Okay, US 4th edition, 2012. Okay, they are referring these two books for this particular units and all. Okay. Both the books I will going to share with you. You can just go through at least a part of some pages. I will tell you this, go to these pages and all, so that something you will be getting more about that. Okay, okay, fine. So here, just look at two things here. First, we are using this generated from uniform distribution. So it is inbuilt functions we have. Okay. So use the set dot seed here, okay, which is 4. Generated from here we are generating the pi observations to just understand how this code works. So the minimum is 2 and the maximum is 5. Like we have value A, we have value B, right? And then you got the value of X and all. So this is the generated observations. Now look at these observations, what difference in here. So these many observations you have generated from the uniform, right? Now we are deleting the last observations, and here I am deleting the from x2, deleting with the first observation. So I'm creating the one more vector here, x1. Here I'm creating another vector x2. Okay. So look at here also we have 4 observation. Here also we have first 4 observation. Now you can just make the plot of your x first. X is this. Just look at it, is not actually uniform. But look at this plot of your this plot is basically for the paired observations. Look at this plot. And here we are trying to just obtain this autocorrelation function. There is a correlation between, see, if I'm not deleting these observations, and if I'm finding a correlation between this x1 which contain 5 observations, which this contain also 5 observations, then definitely, because it is generating from the same observations, there might be some correlation exists. But here it is not required basically, but I have just introduced as a, we have already studied the thoroughly these concepts in your autocorrelation plot and everything. So it is just a function, so you can just understand how it works. Okay. So there will be the more correlations you can observe. Okay, if it is greater than 1 or so, even you can get the more picture from our aim is to be not understanding more about these details. Okay, just generating from this distribution. Okay, that is the basically our aim, our mode. But you can just look at the